Okay, it's impossible to go into great detail on this problem in a 5-minute video, but let's see what we can uncover here. First of all, this algorithm for curve sketching is just probably a series of steps that you go through to prepare for sketching the curve. And this is not a rational function, so there's not likely to be any vertical or horizontal asymptotes. But we could find the y-intercept when x is 0, y is 30. That's the y-intercept right there. And end behavior as x approaches infinity, positive infinity. This term dominates. And if you cube a positive number, it's going to be a bigger positive number. And there's no numerical coefficient in front, so y is going to approach infinity as x approaches infinity. And similar, as x approaches negative infinity, y will approach negative infinity. And that's what this little table shows right here. As x gets bigger and bigger, the y values get bigger and bigger. And similarly, as x gets smaller and smaller in a negative direction, y approaches negative infinity. Now, as far as using y prime and y double prime to find critical points, increase, decrease intervals, that's what we're showing over here. So here's the original function. Here's the first derivative, which we will take over here to employ the first derivative test. And here's y double prime, which we will use in the test for concavity. The first derivative test says set the first derivative equal to 0 and find out what values of x make the first derivative equal 0. And remember, the first derivative gives you a formula for slopes of tangent lines. So when we have the first derivative equal to 0, we'll have locations where the tangent line is horizontal. And if the function changes from increasing to decreasing where that horizontal tangent line occurs, then we've got what's called a relative maximum. And similarly, here's another horizontal tangent line. The function went from decreasing to increasing, so we have a relative minimum at that point. How do you find those points? Well, we solve this equation. We find out that the critical numbers are 5 or 1. Put those critical numbers on a number line. That's where the first derivative is equal to 0. That's what I have f prime here instead of y prime. Same difference. And then pick a test number in each of these intervals created by the critical numbers and find out the sign of the first derivative. To the left of 1, like 0, if I put 0 in this first derivative, I get a positive number. And that means the tangent lines are positive in slope, which means the original function is increasing. So we put an up arrow there. Between 1 and 5, pick a test number, like 2. If you put 2 in this first derivative, you will find that you get a negative number. That means the tangent lines are negative, going downward from left to right, and so is the original function decreasing. And to the right of 5, the first derivative is positive, so the original function is increasing. The fact that we go from increasing to decreasing means that there's a relative maximum when x is 1. How do you find out the y value? You put 1 into the original function, not into the derivative. You want to find out the y coordinate of the point where x is 1 on the original functions. That's where this 37 comes from. Similarly, the function went from decreasing to increasing. So at 5, we have a relative minimum. To find out this y coordinate, you put 5 in to the original function and get the y value of 5. The test for concavity, we set the second derivative equal to 0, solve for x. That's where the second derivative equals 0 at 3. And the sign of the second derivative will tell you the concavity of the original function. In other words, when the second derivative is negative, the tangent lines are decreasing in slope. And that's why we say the concavity, when f double prime is negative, the concavity is downward. And I like to think of negative as a frown. That's how I remember it. When second derivative is positive, the tangent lines are increasing. So we have a smiley face, okay, concave upward. And that means that when x is 3, we have a point of inflection. If you put 3 into the original function, you'll find the y coordinate of the point of inflection. So it's not going to be easy to find the x-intercept for this graph. Eventually, you'll probably learn something called Newton's method to identify the coordinates of the root. But if you plot the y-intercept and these relative max and min, the point of inflection, you should be able to draw a pretty rough sketch of the original function. There you go. Hope that helped and gave you some idea of what we mean by sketching the curve using the algorithm for curve sketching.